name is Andrew Stibberts. I'm an instructor here with Sunset Learning. And we're here to talk about IPv6 security and IPv6 vulnerabilities. So you should see the results there. So looks like in response to the question, have you deployed IPv6 yet? The majority of folks are saying no. It's out there. We've heard of it, but we haven't deployed it yet, which is the majority across the nation, but not internationally. All right, when we start looking outside the United States, we see a much greater adoption of IPv6. And that's kind of what's driving what we're talking about today, because it's out there and folks are actually using it, just not everyone. But okay, so we're going to start using it. And so then I phrased that second question specifically, all right, how long? Because we're not going to, or we have no plans, that answer really doesn't work anymore. That worked 10 years ago. That worked 20 years ago, where IPv6, well, not 20 years ago, but we'll say like 2008, 2009, where IPv6 was out there. It was really optional, but you could say, I'm going to retire before we're going to look at that protocol. But today, 2023, it should be on your plans. It should be on the next couple network iterations, next couple of changes. IPv6 should be in there. We're going to talk about that a little bit. Okay, so thank you for answering those poll questions. Do something a little interesting. So this is not your grandfather's WebEx. We have better tools these days for sharing content and delivering and talking to folks. And so, as I mentioned, I'm an instructor here with Sunset Learning, and so this is my classroom, and so I like to do the classroom style deliveries, and so that's what you get today. So also you can look forward to this if you come back for any training. So again, my name is Andrew Stibberts. I teach a little bit of everything. So routing and switching, security, cybersecurity, little attack and defense, little SD-WAN. I also teach multiple vendors content. We do Cisco, we do Arista, we get into AWS. Used to do Juniper before Juniper took all their training in-house. And so what I'm focusing on this week is kind of the big picture, or this week I should say. Usually I teach a 5-day course. What I'm focusing on today here is IPv6. And so we're all kind of interested, like, all right, from the polls we see it's out there, we know we should start deploying it, but there's usually some security concerns. Folks are saying, well, how does it change the game? What do I have to worry about? So that's what we're going to address a little bit here. So our kind of intro, kind of did that already. Our agenda for today. So yeah, I already did the intro, already did that. So we're going to first kind of set the stage. Why are we talking about IPv6? Why am I, smiling so much when I say you're going to deploy IPv6? Because it's out there. Then we're going to talk about how there are some vulnerabilities, there are some attacks that are similar to what we deal with in IPv4. Because at a base level, it's still the IP protocol, right? Internet protocol, addressing, subnets, default gateways hasn't changed, right? So then there are still some attacks and vulnerabilities that they work the same way. But then there's some new vulnerabilities. And I think this is where we get a lot of the trepidation. Folks are not sure because it's not the same. And they just say, well, if I don't have to, I don't want to get into it. So we'll talk about what some of those are. But I want to say this just right up front. We're only going to be here for about an hour. I don't have time to cover every single vulnerability in IPv6 and IPv4, where you just compare and contrast all the vulnerabilities in 1 hour. Anyone want to hazard a guess? Like, to put it in perspective, in 2022, do you know how many new vulnerabilities were discovered? Just across the world of IT, how many new vulnerabilities came out in 2022? I know I don't have my chat on the screen. Actually, I do have my messages here. 1 million, that's a pretty good number. A millions, it can't get much larger than that there. Well, tens of thousands. So it was just, the last time I checked, it was just over like 44,000. If you want to take a look, if anybody's bored, there's a resource out there called CVE, our Common Vulnerabilities and Exposures Database, where they have a record of all the software, hardware, firmware vulnerabilities that are discovered. So I don't have time in 1 hour to cover every vulnerability. What I want you to take away from this is the mentality of how we're going to approach IPv6 vulnerabilities. And I'm going to give you some resources to flesh out all the vulnerabilities that your environment is going to have to deal with. Excellent. Thank you for that. I'm going to talk about a couple tools that we can use as well, because we're not just going to say, go look up, there we go. Actually, that's one of my resources. 5 points of extra credit to Brian there. We're going to talk about some of the tools that we can use, all right, to secure our environment. I'm going to give you some additional resources as well at the end. Okay. All right. So why IPv6? Why am I saying you're going to use it? All right. Well, what's wrong with IPv4? There's nothing wrong with it. That's the problem. Is everybody uses IPv4, and it's really, it's just 32 bits. So with 32 bits, you get just over 4 billion addresses, 4 billion possible combinations. Some of those get reserved for internet routing these days and versus private internal routing. There's reserved addresses for multicast versus unicast purposes, all the different appropriations of addresses. So unofficially, we've run out. So there's still some addresses in churn. Old sites go down, new sites come up. We find slightly more efficient ways to use addresses, or like we find a large site that's inefficiently using addressing and reapportion those, but we're running out. That's really, you find new sites, especially internationally, where you just can't get IPv4 addresses. Here in the US, there's not been as much pressure. We have more to hand out, but the moment you go over to Europe and Asia, there have been IPv6 only sites for years over there. So just now we're getting the pressure here in the US. For IPv4, I mentioned public and private, network address translation, where we translate from our internal private addressing to public addresses. That works so well. I like to say it works too well. If any of you have taken CCNA or anything with me, you probably heard me say it works too well, because it removed the pressure to start adopting IPv6. And then there's some of what I've been mentioning earlier, where there's some I want to say trepidation. There's some unsureness. There's some fear where you say, it's new, we're not sure exactly how it works, and there's nothing wrong with IPv4, so why bother? I hear that all the time in the classes. It just says, there's no need. No one's forcing me to. It's not broken, I'm not fixing it. And that's a valid answer. But it's already out there. When we look at international deployments, like I said, IPv6 only exists. And even here in the US, if anybody's worked with AWS or Azure, any cloud resources, you look at ISP backbones, and especially all of your cell phones, almost every major cellular network these days, IPv6 is widely used. So it's out there. Just we're not all using it in our enterprise networks today. Right? We've got a lot of federal requirements as well. That one's actually kind of funny, because the DoD, the Department of Defense, they had a goal of being fully IPv6 compliant back in 2008, and that didn't really happen. So, but nobody got in trouble because there wasn't any pressure. Now, almost 20 years later, now it's coming around where we really have to deploy. Okay. So short answer, we're running out of addresses. Okay. Now let's get into the security side. Okay. Actually, before I say that, before I get into the security side, when we say the IP protocol, right? Not IPv4, IPv6, when we say the IP protocol overall, right? It's a connectionless protocol. You've got your network and host addressing. We've got subnets. None of that changes when we start going from IPv4 to IPv6, right? Yeah, but we'll talk about some of the transition mechanisms as well. So when we talk, because they're IPv4 and IPv6, they're still the IP protocol and the functional side of it hasn't changed. Well, there's a couple different types of attacks that still work the same. those have not changed. Therefore, the protection mechanisms you're going to deploy are exactly the same, just for bigger addresses. So first off, man in the middle, MITM attacks. Now, I will acknowledge man-in-the-middle attacks can occur at multiple layers in the OSI stack. You can't have a webinar on networking without talking about the OSI model, right? That's the rule. You have to mention the OSI model at least once. So you can do layer 1 man-in-the-middle attacks, layer 2. Here where you go for the MAC addresses, you get inline devices. Those exist. We're not really talking about those today. We're focusing in on layer 3, we're focusing in on the IP addressing, so that's another layer where man-in-the-middle attacks can occur. So what are some of the options? Well, first off, default gateway updates. When we start looking at the hosts, we can use tools like, or routers, we can use tools like ICMP redirects, the Internet Control Message Protocol, ICMP redirects to advertise better paths. We can do similar things in IPv6. And then routing protocols. Anyone use routing in environments? Routing protocols, I should say, not just routing overall. Pretty common protocols like I can spell today, OSPF, or growing in popularity, ISIS, your intermediate system. And yes, ISIS is making a comeback with IPv6. We see some growing popularity with that, especially in satellite, cellular, ISP environments. With routing protocols, attackers plug in, and it could be actual routing hardware, it could just be a laptop pretending to be a router, and they can form a malicious neighbor relationship if we don't secure our protocol. These are well-documented protocols, well-documented multicast addresses, how we craft the hello messages to form neighbors. So how do we lock this down in IPv4 and the same in IPv6? Well, either static configuration, where we manually define neighbors, that way we can't get any malicious neighbors, passwords on our routing protocols. The attacker doesn't know the password, they can't form a neighbor relationship, therefore they can't redirect our traffic. It's the same kind of attacks in IPv6, and so we're going to do the exact same thing. Just where this becomes interesting is the dual stack approach. Does anyone, when we say dual stack with IPv6, does anyone know what that means? What's a dual stack approach? Using dual stack? Yes, IPv6 and 4 in one environment. You're running both at the same time. And that makes it kind of interesting because we could have all the security options deployed for IPv4. You spin up IPv6. If you don't choose to deploy the same security options, they don't automatically inherit. And so we've done all this wonderful IPv4 work for years. We secured it. But now when we start spinning up IPv6 at the same time, if you don't go through the actions of doing the exact same security steps, they're vulnerable to those attacks. So you'll hear some recommendations either from like the NSA or CISA, which I'm going to talk about some of that. You'll hear some recommendations where they'll say, preferably, you should do IPv6 only, because that way you don't have to worry about securing one protocol and somebody forgets to secure the other protocol on that one router in that one warehouse. If you only run just IPv6, you only have to worry about securing the IPv6 protocol from these known attacks. But that is an option. There's nothing wrong with dual stack, but it does mean you have to make sure both get secured. Another vulnerability that's still out there is packet capture. Now you say, well, wait a minute, packet capture, if it's wireless or wired, that means the attacker is within range of my wireless traffic or physically in my building. Is that possible? Absolutely. If you are a valuable enough target or any plain text traffic routing outside your environment, which we try to avoid, but it still happens, anything plain text, the attackers can see. And we say in a large enough environment, not everybody knows everybody. Attackers will walk through the front door. They'll dress in business casual, have a nice briefcase or backpack. They'll sit in the empty cubicle, and now they're there. Now they're listening to any traffic in your environment, and if they can get a copy of it, well, then they can read it. It's plain text, or they could even forward it off to a destination, to the actual routers. They can play on the man-in-the-middle attack, forward off the destination, so your users don't even know what's happening, but the attacker got a copy of it, so then they could manipulate it. They could save it for later, whatever they want to do with it. Even encrypted traffic today, this is a problem. Now, don't worry. We're not worried about AES ciphers being cracked. Today, when we talk about encrypted traffic, we're using TLS, right? Our transport layer security, using our AES encryption protocol. It is possible for attackers with a man-in-the-middle attack to pretend to be a server to a client and pretend to be a client to the server. So both sides think they're talking to each other. They're actually talking to the attacker. And the attacker has two TLS connections, not just the one going from the client to the server. So the traffic actually goes through, but it's going to the attacker first. The attacker can decrypt it from either session and then re-encrypt it before forwarding it on. We do the same thing. By the way, our next generation firewalls, we do the exact same thing for traffic that we want to look at, but the attackers have that capability as well. So in this case, when we look at the IP protocols, IPv6 has built-in IP security, authentication, and encryption mechanisms, but they're not enabled by default. And so if we have any plain text traffic or we get a man-in-the-middle attack, then that means that the attacker can still see and copy our traffic. That has not changed. So what do we do for something like this? Well, we'll go in and we'll use identity-based access control. We'll make sure that only the correct devices are connecting to our environment. We'll use traffic analytics to monitor traffic patterns, who's generating which applications at which time of day, to make sure that we don't see something weird, some unusual traffic patterns occurring. But if we don't do any kind of internal monitoring, yeah, all they have to do is walk in, plug in, and sometimes just listen. And at that point, they can see traffic moving across the network. Maybe do a man-in-the-middle attack. Rogue devices. Again, building on that, hasn't changed. If an attacker is on site, they can plug in their own hardware. And it could be a full router, switch, access point, maybe a smaller router. Those that don't attract too much attention. But if they're really trying to evade physical detection, a simple Raspberry Pi. Anyone played around with some Raspberry Pis? Cool, really cool little pieces of hardware, but it is not hard to build a little Ethernet port, a board, the processor, and you can slip that in behind the filing cabinet in a cubicle somewhere. So that piece of hardware is on site, plugged in, and not immediately physically seen. So, and from that could be their launching point to either, again, man-in-the-middle attack, DHCP attacks, or just monitoring whatever their goal is. So how do we prevent against this? Well, again, let me back up a step. This doesn't change, whether it's IPv4 or IPv6. The addressing changes, but this kind of a vulnerability of on-site hardware, it's still exactly the same. So similar to the preventing packet capture attacks, just preventing rogue hardware in the first place. We'll do authentication, 802.1x, or MAB if it doesn't support .1x, multi-factor. And then again, traffic analytics, there's where the zero trust comes in, monitoring what does normal look like internally. Also for high value endpoints, if you've got the critical servers, the critical endpoints, if you want to do a little more manual configuration for who their neighbors are, what their local host file is for DNS resolution, default gateways, that's more work. That is more input from the admins. Maybe not us, maybe the junior admin will have them do it. But for the critical devices, we're going to make sure they're not talking to a rogue. It might be worth it. Maybe not for every single laptop, but definitely for the critical ones. Another similarity is 4 through 7 attacks. So when we say 4 through 7, we're again, back to the OSI model, we're going up to the transport layer, going up, session, presentation, application. If there are vulnerabilities based on TCP or UDP, there's vulnerabilities based on the application itself, that has nothing to do with the IP protocol. There's some considerations about identifying the types of traffic we're carrying using the IP header, but if the vulnerability is in the HTTP, the web server itself, and how that was deployed, then IPv6 is, again, just the transport. So it could be SQL injection attacks, maybe a SQL server, cross-site scripting, your different flavors of attacking web servers, any kind of vulnerabilities in the browser itself, the user agent on the host machine. IPv6 is just the addressing. So the tools that we've been using for years to secure that in IPv4 still will do that for securing against those attacks in IPv6. We'll talk about a couple of those. Yeah, next generation firewalls, DNS filtration. But those tools have been updated for years to support IPv6 filtration, and it's the same kind of security mechanisms. We also have recommendations. I forgot to put this on the slide here. We also have the recommendations from OWASP, your online web application security project, where that's an organization that has a number of recommendations for how to secure web servers, SQL servers, how to deploy these applications correctly so they're not vulnerable to these kind of attacks. Doesn't matter what the addressing is. That hasn't changed. And of course, denial of service. Anyone ever had their network denial of service? I don't have hard numbers on this, but it might be one of the most common types of attacks out there, because you get all the script kiddies, the entry-level attackers. This is what they do. And so these haven't changed. ICMP, we have the ICMP version 6 and IPv6, the TCP SYN flooding attack, or fragmentation flooding. Now, all of that's, it all works the same. So our protection mechanisms are going to be exactly the same, because it's just the transport. Are you seeing the pattern here? For the really basic attacks where it leverages something else, not just the addressing, or where the attack leverages just the addressing, it's going to be the same tools. And so we don't have to reinvent the wheel. We don't have to buy all new security hardware. It's going to be a similar way to protect our environment. All right. Now, this is kind of interesting, because this is an attack that is similar, just entirely new naming. So IPv6 replaces the ARP mechanism with its neighbor discovery mechanism. Instead of doing broadcast-based resolution to resolve the layer 2 to layer 3 addressing for a neighbor, ARP does a broadcast-based discovery, unicast reply, learn what's my neighbor's MAC address. Instead of using that, IPv6 has its own built-in neighbor discovery mechanism, where we do our neighbor solicitation and neighbor advertisement messages. It's multicast. We just do a multicast advertisement, unicast reply, but it's not a separate protocol. All right, it's like ARP is separate from IPv4. We deploy them both at the same time. Usually works well, but this is just IPv6. It has this function. Okay, so that's interesting. We don't have to deploy a separate protocol to resolve what's the neighbor's layer 2 address. What's the vulnerability? How is this a problem? Well, it was developed with a functionality focus, not a security focus, where if we get updates to our neighbors table, that can update what's the MAC address that we're going to use, similar to an ARP injection attack in IPv4. The latest is greatest, whatever gratuitous, whatever unasked for update where the neighbor's information can change which MAC address we're referencing. This also gets interesting, can be used for recon. When we look at a 128-bit addressing with IPv6, 128 bits, the first 64 bits is going to be our network portion. The last 64 bits is the host portion. Where that gets a little interesting is with 64 bits of host addressing, Does anyone know how many possible addresses there are with 64 bits? How many possible combinations you get with 64 bits? It's a lot, right? With IPv4, with 32 bits, getting there, 4 quadrillion. I gotta look at how many numbers quadrillion is. 340 trillion. Will that be for when we start getting to our 128-bit addressing? So with 128 bits, you get 3.4 trillion addresses overall. It's one of those weird words like UN decillion. Not sure how to say that. It's so many addresses, it's ridiculous. When you look at just 64 bits, you get 18 quintillion, QU, 18 quintillion addresses. That's a good amount, right? So how long do you think it takes to do a ping sweep or port scan that many addresses? Years. It takes years. It's a problem. Like reconnaissance, actually, I'm getting ahead of myself here. Reconnaissance changes from an attacker perspective when you start looking at IPv6. But this could be used because it's multicast based. If an attacker listens and they hear the multicast of neighbors trying to resolve each other's MAC addresses, they could use this for their recon, not just for a redirection or man-in-the-middle attack. So similar to the ARP attacks, that's why I put it on this section, similar to the ARP attacks, leveraging the neighbor discovery mechanism, but a little different. It helps with the recon as well. Now, if I'm talking about this, we probably have a fix, right? If I'm aware of this problem. So on our switches, we've got tools like IPv6 snooping, where in the Cisco terminology, they call things like glean and binding tables, where we listen. We see the DHCP traffic when it comes in. We listen to the neighbor resolution info, and we build our neighbor binding tables of what the correct info is, where those PCs are plugged in, what their IP and MACs are, right when they connect, right when they start talking. And then if somebody tries to update that, air quotes for anyone not watching, but air quote that to redirect it to a different device, we can flag that and we can drop it. We can also do suppression, where if we don't want an attacker to use this for recon, we can have the switch from its binding table. Whenever a neighbor discovery multicast comes in, neighbor solicitation come in, we can have the switch stop it and either respond on behalf of the clients or convert it to a unicast. Because if the switch knows where those hosts are plugged in, it doesn't have to flood it out everywhere. We just unicast it straight to the host that we're trying to resolve for. So the attacker can listen all day. They're not going to hear who's actually out there. So great options to help lock down these attacks. So like I said, very similar. We've got DHCP snooping, that dynamic ARP inspection on IPv4, but those were choices. We had to turn them on. So back to the dual stack mentality. If we're going to deploy IPv6, we need to deploy the IPv6 version of these options to secure against this similar attack. Okay. So you see there's a couple similarities. All right, and that's not all the similarities. Again, I've only got about an hour here, but that you start to get the idea. Where it comes to just basic routing, default gateway, neighbor resolution, IPv6 will use slightly different terminology. We'll have a couple more addresses we could reference, but the tools we're going to use, the attacks and the ways we prevent them, they're going to be almost exactly the same. So now let's get to the fun part. All right, how's it a little different? All right, recon. I was getting ahead of myself here because it kind of made sense in that previous slide. But so with a 64-bit subnet, 18 quintillion addresses, someone ran the numbers once. Don't quote me on this, but I'm trying to remember exactly what I read. It works out if you can do a ping sweep, just ICMP echoes at about 400 megabits per second, it would take something like almost 10 years to ping sweep a single IPv6 subnet. And if you have multiple subnets, right, that's going to take several decades. So from an attacker perspective, If you're doing any kind of planning, any kind of security to prevent possible attack attempts, when you start looking at it from the attacker side, you say it's not even worth it. Well, why? That's a waste of time. There's got to be something else for me to learn which hosts even exist, and then to go scan those for vulnerabilities. So that's where we need to start locking down, or continue to lock down, our critical endpoints. So DHCP servers, DNS servers, default gateways, because those are the devices that everyone talks to. And that neighbor discovery, neighbor advertisement we just talked about, they're going to have a neighbors table of all the devices that they've resolved the MAC addresses, who they're going to respond to. So securing the critical endpoints, not every single laptop. Those are still important. Or don't neglect the security on your laptops, but making sure that we've got the code updated, automatic updates from Cisco or whatever vendor we're using for security definitions. Make sure we've gone through our compliance checklist, locking down those critical endpoints, because we know those are going to be an emphasized attacker focus, because it's for recon, not just for trying to get into the DNS server or get into the DHCP server. The other option is also the allowed list model. Does anyone know what an allowed list is? You didn't know there'd be so many questions today, did you? You'd have to participate. What's an allowed list? You have a denial at the end, absolutely. It's a list of sources, applications, what we are explicitly permitting, and everything that's not on that list is denied. It's what's allowed. And so that's what we're looking at here is we can explicitly identify which subnets, which applications these devices are allowed to talk to or receive traffic from. Yes, the terminology's been updating. You will still see the terminology whitelist and blacklist out there. It's still live on some Cisco tools and some of their documentation. They've been updating it to allowed list and blocked list, block EB, which, check my clock here, slight tangent. When they first tried to make the update, they wanted to do block list, but in network automation, we already have blocks and lists of blocks. They couldn't do block lists, so now we have blocked list. But so yes, you will still see the legacy terminology out there. If you Google search either one, you'll still find the tools. But so yeah, we can use the allowed list model to lock down who we're actually going to respond to, not just any devices out there. But that is a little more work. I do acknowledge that. Another new attack is Slack. Slack, the stateless address auto configuration. So the idea here is, we've had DHCP, dynamic host configuration protocol, handing out addressing and options for years with IPv4. Well, so one of the mentalities in IPv6, what the developers did is they said, if we can just build that function into the protocol, then we can just deploy one protocol and it can do all this work for us. We don't have to deploy multiple protocols that work together. Kind of like ARP, who got replaced with a neighbor discovery mechanism. DHCP can be replaced with Slack for simpler environments. Slack doesn't have all the functionality and all the control that DHCP had, but it's similar. It's great for simpler environments. And that's a default. When you start looking at spinning up IPv6, you kick off the protocol on a router. We'll have a happy little router here. We kick off IPv6. We add an address to the interface, and then it will start periodically advertising router advertisements. And those router advertisements contain the prefix, the subnet that's on that interface, a couple options, and the fact that that router can act as the default gateway. Your clients run Windows, Apple, most of them are running Slack by default. When they get a router advertisement, they give themselves an address in that subnet. They set that router as their default gateway. They're up and running. It's an addressing and default gateway mechanism. Sounds a lot like DHCP, right? So that's a problem because that's a default. When we look at our hosts, if they come online and an attacker sends Slack messages, sends a router advertisement, setting themselves as the default gateway. The client doesn't know any better. It gives itself an address in the attacker's subnet, sends the traffic to the attacker, and then the attacker can forward it off to our router, but it went to the attacker first. Classic man in the middle. Or they can just use it for recon. Again, learning who's out there. That's just listening to the Slack traffic is how the attacker can learn which hosts even exist. Because when a host comes online, got my happy little host over here. At boot time, they're going to send out a router solicitation. And the router solicitation, it's a multicast that targets every router. It's a multicast that targets every router, but it's a multicast. So it goes out everywhere. And so that's a problem, right? Because the attacker can just listen and it sees the client router solicitations at boot time, tells them which clients are out there, who to attack. So great for recon, great for man-in-the-middle attacks. We don't like that. DHCP version 6. DHCP still exists, right? It's still a 4-message process, but instead of broadcast, now it's multicast. There's your multicast address. You know, okay, what's the problem with DHCP? Why are you putting that on the list? Well, the problem is it doesn't use just the MAC address. It uses a unique DUID, a DHCP unique identifier, which different vendors, you can build it based off of time stamping. You can use it off of random number generation. You can use the MAC address, but for tracking purposes, if you've ever done a cybersecurity investigation, if you're ever looking internally trying to figure out, well, which host was generating that traffic, if you want to look up what's the MAC address, or tracking down the whole context around a device, DHCP info is great, but if it's not actually the device MAC there, well, that's one more thing that we have to keep track of. And so that's part of IPv6 is it doesn't just use the MAC address anymore. Okay, well, how can we fix this? Well, first off, for the for the Slack mechanism, we've got some options like router advertisement guard, where this is a default when we start looking at like Arista Wi-Fi on our devices. We can deploy this on wired Arista Cisco interfaces as well, where if we see a router advertisement come in from an edge port, we block it. Kind of makes sense, right? We should never see a router advertising, the advertisement from the router, come in from a port where the users are plugged in. That's not where the routers are deployed. So we'll just drop it right away. All right, similar to our DHCP snooping back in for IPv4. But for IPv6, we also have, for the DHCP version 6, we have DHCP version 6 guard. So again, similar DHCP snooping in IPv4, where if I've got DHCP advertisements, the attacker's trying to do a man-in-the-middle attack, not just listening. If they're trying to advertise acting as a DHCP version 6 server, we see the advertisement coming in from a edge interface, not where the DHCP server is plugged in. We can drop it right there on the edge. Some of those, like the router advertisement guard, like I said, Arista Wireless, they'll do that by default. But the DHCP version 6 guard, router advertisement guard, when it comes to our wired interfaces, we still have to choose to turn that on. And so that's something new to watch out for. Smurfing. It's an actual word, smurfing attack. It's not just little blue guys running around. The smurfing attack, I have a lot of fun in our cybersecurity training. Smurfing is a combo of amplification and reflection. So amplification, where when you look at a subnet in IPv4, right, /24, keep it easy. You got that last address, 255, right? The broadcast address, the last one for the subnet. You send traffic to that address, it hits everyone in the subnet. If an attacker wants to, not just for recon, but they want to have a small amount of traffic turn into a larger amount of traffic, they'll do that. They'll target the broadcast address. And so one ping, let's say I've got a subnet with 200 devices, one ping becomes 200 because it gets sent to every device. And then the reflection attack, in the source IP address, the attacker doesn't put their own IP, they're trying to hide their presence. They put the source IP address of who the actual victim, who the actual target is. It could be a server, laptop, whatever the target is. And so the ping goes out, it amplifies to 200 devices, and those 200 devices all reply back to that one source. And so that floods, that becomes a denial of service attack. It's more traffic than the attacker could generate by themselves, right? That's your smurfing attack, combo of the amplification and reflection. So how much traffic in your environment, think about your applications, your company, how much traffic do we have that actually targets the broadcast address of a domain? Of a subnet. Not a lot. I mean, I've yet to find a good use case for talking about that. We usually, if we're talking with multiple devices, we use multicast. And so actually there's most vendors, they will actually filter traffic going after the broadcast address by default because of attacks like this, because it's not used for normal traffic. You can open it up if you want to. I don't recommend it unless you absolutely have to. That was something the vendors had to implement though. All right, because in IPv4, that's broadcast addresses. That's just the way, that's what was designed for functionality, not for security. It was designed if you needed to talk to everyone in a subnet, use the broadcast address. So a vendor response was necessary. The difference in IPv6, in the IPv6 protocol, traffic that is targeting the multicast address, targeting, not targeting the multicast address, traffic that would be amplified like that, where we use multicast, not broadcast, that's automatically blocked, just built into the RFC standard, which means that if you do want to use that for some of your internal applications, we have to go explicitly permit that through our firewall, through routing, but built into the protocol, not from the vendor, that's going to be automatically filtered out. So that's a little different there. I know I only have a little more time left, so we'll go pretty quick through these. So one of my last couple questions here. What's the difference between a virus and a worm? It's malware, right? Yes, they're both malware, they're both malicious software. But what's the difference? Worm self-propagating, so good. Excellent. And you all must have attended some of my security training, earlier. This is awesome. You all have the answers. Excellent. So exactly, a virus is propagated. A virus spreads by attaching itself to some other host. Could be email, could be web traffic, but a worm can self-propagate. Well, the difference. Okay, well, how is this different in IPv6? Again, who's out there? What the recon? What valid hosts even exist? Viruses will still work. All right, viruses aren't going to change much because those are still relying on some other application where that's got the valid neighbors table. That's awesome. Gets you some extra credit for that answer. Yeah. Anyway, the viruses can propagate using the regular applications, which those are using the regular neighbors table, default gateways, so they don't have to learn where to send the traffic. The host did that already. With a worm, it's a little harder to propagate if you don't know what the actual addresses are. So worms, I think we're going to see a little less use there. All right, well, unless the attacker has some kind of recon option built into the worm or a multi-stage attack. But that's going to be a difference in the types of malware that we start seeing more of, just because of the way the underlying addressing works and how many addresses there are to go through. From a cybersecurity, from an investigation standpoint, addressing addressing, tracking the addresses becomes a little more interesting. IPv6 has security extensions where a host machine, when it gives itself an address in a IPv6 prefix, we can use the EUI 64-bit address, the extended unique identifier, where it can use the device MAC address, pump 48 bits, pump it up to 64 bits. We'll flip the universal local bit. We've got a duplicate address mechanism. There's a couple options there that I'm getting off track with, but we don't have to use that. What we can instead do is random addressing. I'll have to take a look at that. That's an interesting one. What we can use is instead random addressing, where you may have seen this in the last several years with Apple and Windows and even your phones, the randomized MAC address option, where it says whenever you connect, you want to use a different MAC address. And so it's using a PRF, a pseudo-random function, to come up with that number. So when you are investigating, some cybersecurity investigation occurs, and you're trying to find Bob's laptop. I apologize if anyone's here is named Bob. Bob is my usual example in all my examples. Bob and Alice. And so we're trying to find Bob's laptop. Well, what's the MAC address versus what's the address it was using when it connected? Either we have to turn off these security extensions, or we have to have some kind of tool, some kind of SPA, where it's pulling that DUID I mentioned earlier, the DHCP unique identifier, whatever layer 2 unique identifier came up with today to what IPv6 address it got, and then we correlate that with all of our logs, correlate that with our neighbors table. Anyone know what a SPOG is? I'm one of the few people who uses that acronym, SPOG, single pane of glass. It's kind of a marketing term, but most tools, most security tools these days, we need to go to one tool that is pulling all of this info in. So that way, when I'm trying to find that one machine, it doesn't matter what address it came up with today. I've got that from the logs, I've got that from the neighbors table, and I can still get that context. For tracking attackers, well, spoofing addressing still works. I should have put that on the earlier section with IPv4 similarities, but it's not hard for attackers to spoof IPv6 addressing. What can we do? Well, there's only certain IPv6 addresses that have actually been assigned, actually been deployed. All right, so going back to IANA, all right, going back to the RFCs for which global address ranges are actually in use. And so we start looking at our 2000 /3, identifying the global internet routable addresses. Other address ranges like 1999, 2222, other addresses where the first field, it doesn't start with 2000, those are out there, but they haven't actually been assigned yet. So one of the first things we can do to filter out spoofed addresses, to keep attackers out, is filter addressing that's not actually assigned by IANA yet. And then we can do similar routing-based filtration, similar to our URPF, unicast reverse path forwarding, where we can verify, is the subnet that we're receiving traffic from, is it in the direction that we receive the traffic from? If we receive traffic on an interface, would we go back out that interface to get to that subnet? And that way, if an attacker is spoofing some of our addressing, but from the wrong direction, we can see that. So similar options, but with IPv6, there's just so many addresses. First steps is just filter the ones that folks shouldn't even be using yet. Why am I mentioning this? Why are we mentioning identify internal addresses, identify attacker addresses? Yep, that's what I was mentioning earlier, is that there are similarities, and then there's a couple, yep, that's what I was mentioning. You've got the exact same, yeah, really, you've got the same vulnerabilities in IP4 and some of the new ones, yes. But not just based on attribution, not just based on the MAC addressing. Like I said, there's a number of other vulnerabilities I don't have time to get into, where it goes into the encryption, goes into the authentication. I just have a couple more slides to talk about, but yes, it is very similar, plus a couple extra vulnerabilities. Yes. Why am I mentioning attackers addressing? The pyramid of pain. When we want to, again, perform a cybersecurity investigation, we want to gather info about the attackers to maybe share that with the world so somebody else can benefit from our experience. That's where we learn about their tactics, techniques, and procedures. We learn about information that can cause the attacker pain, because then they can't reuse those addresses, reuse those domains later. All right, one of my last parts here is ICMP types. Everyone just filters all ICMP traffic in IPv4, right? Because nobody needs ICMP, maybe just the IT department, but no internal users need ICMP for anything, right? Of course. So we just filter all ICMP traffic. Some environments do that, but you can't do that in IPv6. There's a couple different ICMP types that we use for that neighbor discovery mechanism, for the Slack mechanism, I mentioned those right there. But we also, the critical one here, there's a couple others, but these are the ones I really wanted to mention. The critical one is PMTUD, Path Maximum Transmission Unit Discovery. In IPv6, key difference from IPv4. In IPv4, fragmentation is done by the network devices, routers, switches. In IPv6, fragmentation is done by the client, the endpoint itself. So they will send a series of packets with increasing size with the DF, don't fragment bit set, that's ICMP messages, until they get a response back, the packet too big. So that tells them how big of a packet can I send through that path. So if I just filter, I have to double check on that. Well, because the responses, I believe we're going to just match the MTU size that we get when we're doing a download or transfer. I'll have to double check on that. I believe that's correct. Yes, the source, whatever transfer we're going through, we're going to do fragmentation if necessary. I'm drawing a blank on that. I'll double check on that when I sit down here when we get into our Q&A section here. I'll double check on that one. Lost my train of thought there for a second. But yes, so if we just filter all ICMP traffic, the testing from the client to the destination, that'll fail. And then the response, the packet too big, telling them what size MTU to use, that won't go through. So all of our TCP connections won't work. So all of our filters and firewalls these days, they all support selective ICMP testing. All right, but we can't just block all ICMP traffic, not anymore. All right, the tools that we're going to use, we're still going to use the next generation firewalls. We're still going to use IPS devices. I mentioned Snort as an example. I mentioned traffic analytics a couple times. Internal baseline pattern monitoring. That is one of those tools which using correlation engines like AI and machine learning. I love how AI is in the news every single day, and they never quite use the terminology right. But yeah, AI and machine learning, using that to monitor what's happening internally, what does normal look like, and then spotting a difference. That is so helpful these days. We talk about AO21X, multi-factor authentication, MAB, using tools like the Identity Services Engine. Or if you want to go online, we can use tools like Azure AD, but using something to authenticate every device that's connecting in. So we have no unexpected, unknown devices. Where did that IP address come from? We know every device, where it's plugged in, how authenticated, what kind of traffic it generates normally, or if it's new. The endpoints, we still have host-based tools where we didn't get into the encryption or the fragmentation, but there's options where attacker traffic could still, in IPv6, still bypass your firewalls, still bypass your filters, and it gets down to the host itself. So we still need that layer of security on the host. We've got tools like Secure Endpoint, was formerly called AMP, your Advanced Malware Protection, now we call it Secure Endpoint, where it's host-based firewalls, host-based IPS, still do file submission to the cloud, and I can't stress enough, multi-factor authentication. Today, MFA is easier than it's ever been before, where we use notifications on your phones or tablets to say yes or no, is that actually you connecting to the server? You don't have to type in the RSA token anymore, type in that 15-digit string, which changes halfway through. It is not hard, and that way we don't have to worry as much, because we've got that additional layer of which devices actually connected in and start sending traffic internally. And then this is something I like to recommend for every environment, no matter the size, IPv4 or IPv6, just across the board, cloud-based DNS filtration. All right, Cisco has their umbrella tool. There's other vendors, and they're not the only one, but I like Cisco's, not just because I teach their training, but because they have a larger sample size to compare to than anybody else. One of my last question. What percentage of attacks, what percentage of malware uses DNS in some form? Throw out a number. What percentage of malware uses DNS for the delivery, for the command and control, for the exfiltration? How much does DNS get used when it comes to malware? Anyway, throw out a number. 20%? Okay. Anyone else? 75? 70? 90? Got some numbers all placed. 80. There we go. So we got a couple higher numbers there. All of it. Not quite all of it. Not quite all of it. 42.5, 100. All right, we got, thank you. A lot of great answers there. So the number will vary depending upon exactly which report you read, Forbes, Gartner, Cisco's annual security report. Over 80%. Over 80% of malware, that's a safe number to say, it uses DNS in some portion, either for the delivery, the actions on objectives, periodic command and control traffic, something. So monitoring and filtering DNS traffic, every environment, no matter the type, no matter the size, every environment should have some kind of DNS filtration tool. Because if we can cut that, we can cut the majority of malware. We can also use it to enforce web policy. No gambling traffic at the office. So I'm going to put these resources. Okay, hopefully this is helping you with the mentality here. There are some attacks that are the same as what we saw in IPv4, but there's some new considerations based on the size, number of addresses, the extensions, some of the new functionality. And so we're going to use the same tools we've been using, but we do have to deploy the IPv6 side of the options as well. So I'm going to put these links in the meeting chat. I think maybe my fellow panelists can tell me if we're going to, I think we're going to put the slides available as well, available online. I'm going to put these links in the meeting chat. Here are a couple of resources that I found that I think you should take a look at. The Internet Society has a list of various blogs and articles and research where if you want to go more in depth to more vulnerabilities and how to protect them, they got a great list there. Someone mentioned MITRE earlier in the session. MITRE has their attack framework, their CVE database, where you can look up what are the known attacks, what are the known vulnerabilities, again, to educate ourselves more about what's out there. There's some recommendations from the NSA and CISA. You may have heard of the NSA. They're pretty big, National Security Agency. CISA, your Cyber Security and Infrastructure Agency. They're the, I should say, the protocol, the control arm for the DoD and how their network should be deployed. They've got some guidance. They've got some recommendations for how to secure their environments. I found that very helpful even for an enterprise environment, not a military or government network. I found those very helpful to think about, well, if they're doing those steps, I should probably do something similar because I'm going to be facing some of the same levels of attackers, international, cyber criminals that everyone has to deal with. So those are some pretty good recommendations. And we mentioned some first hop security options like router advertisement guard and DHCP guard. So got a list from Cisco about some of the options they've got there. And again, other vendors do similar or the same options. Just everybody knows Cisco, and so they're a great one to reference. If you need some more training on this, if you say, this is great, I want more, all right, I get no commission on this. I'm just saying, I think this is a great idea. We have a full 5-day class called IPv6 Fundamentals, Design, and Deployment, where it's not just security. If you say, I want to know more about IPv6 overall, All right, so I am more comfortable when I have to deploy that. I've seen it, I've configured it, I know what the considerations are. We've got a whole 5-day course just on IPv6, and we do talk about security, we talk about ACLs and filtering and allowed lists, we do all of that. But you see why I said right up front that I can't cover everything. I started scratching the surface in 1 hour, but there's a lot of similarities. There's a couple new things. There's a couple differences. We've got the tools. We've got the training. We have the resources. It's just a matter of actually going through the steps, going through the checklist. All right. If we're talking about a problem. It's a known problem. There's usually a solution. All right. So let me know if you have any questions. I'm going to check the chat log here. Any questions? Feel free to reach out, and we'll go from there. Thank you all for attending. Yeah, Sunset Learning, we've been around for several years now. We used to be called CTI, Colorado, CCTI, Colorado Computer Training Institute. Then there was a purchase with, I think it was Dimension Data, or Deep Data came first. And then Sunset Learning's been around for just over a decade now. But we do training across, like I said, multiple vendors, almost all areas of Cisco. Unified communication, security, wireless. We helped write the books for some of the Cisco training. Like a lot of all their new unified communication, it was a number of the instructors, not myself, but a number of the other instructors here who do the unified communication training. They actually wrote that courseware. So yeah, we do a lot. So yeah, if there's any other questions, let me know. If not, we'll close the meeting out here in a little bit. Hope everyone has a great weekend.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.